Run out of frame if it starts going poorly.
All right, when you're ready.
Hello everyone, my name is Dominic and this is my AP research presentation on neuropathy, quantifying perception, and nerve development. So the specific question I attempted to address with my research was, can a correlation between finger size and one's perception threshold be determined? We'll talk a little bit more about what perception threshold means and how it's measured in just a second. But before that, I want to talk about how I came to this topic. So believe it or not, I didn't enter this class with a burning passion or a vast amount of knowledge on peripheral neuropathy. But what I did know was that I wanted my research to be related to some kind of biology, as that's what I plan on studying in college, and it's a field I've just found very interesting to study in high school. And even further within that spectrum of biology, I wanted to do something involving medicine, as that's a field I might pursue in the future, as well as it being a topic that I really enjoyed writing about in 11th grade AP seminar. I also knew I wanted my experiment to be hands-on, sort of meaning that it would be something where I could interact with subjects as I collected data, rather than just using surveys. I knew this was something I wanted after participating as a subject in AP Research Students Projects as a junior, and just having a really positive experience with that overall. So I just thought it would make collecting data a much more enjoyable process throughout the year. And lastly, I knew I wanted to primarily use quantitative data, as I wanted my question to have a definitive sort of answer at the end. And I think that a numerical set of data is the best for that and allows everyone to know how you came to your conclusion. So I used these 4 guidelines to start thinking about questions that would have a procedure that was hands-on, quantitative, and related to medicine and biology. After cycling through a few questions, I found inspiration while attending the annual Inspire conference held by the Institute of Medical Engineering at the University of Minnesota. The focus of this year's conference was diabetes and all kinds of devices used to diagnose and treat diabetes. It was here that I first learned about neuropathy, as it is one of the leading complications of diabetes. After attending the conference, I shared what I'd learned and what I'd found interesting from the conference with my dad, who was able to connect me with a biomedical engineer named Patrick Camilleri. Mr. Camilleri, as it turns out, helped develop a device that is used to help diagnose and monitor neuropathy called the BUMPS test. The BUMPS, as you can see here, the BUMPS test is a checkerboard smooth plastic board with several tiny bumps of varying heights that are placed in circles unknown to the testing subject. After the subject is assigned a tile to feel around, they are asked to determine which of these 5 circles they detect the bump in. And based on what size of bump the subject is able to detect, they're assigned a corresponding score, which is known as the perception threshold. So after speaking with Mr. Camilleri, he was able to help me come up with some of the gaps in the research, in his field of research, that I could address with my question using this test. Mr. Camilleri had told me about trends that they saw in data collection, including women and children being able to consistently detect bumps that the average older man could not. Based on these trends, I came up with the question, can a correlation between finger size and one's perception threshold be determined? To answer this question, I used a quantitative correlational study. This means I would be collecting my data by taking measurements of subjects' fingers and running them through the BUMPS test to find their perception threshold. After that, I would take these 2 sets of data and compare them in attempts to find a relation between these 2 sets of data. So the goal of finding this correlation is to better understand how sensory nerves are distributed in the body, as well as establish a more accurate baseline perception threshold for people at risk for neuropathy. So now that I've covered what my question is and how I came to it, let's talk about some of the science behind the question. The most important scientific concept to understand is just what peripheral neuropathy is and how it affects the body. Neuropathy is a disorder that affects the nerves that are responsible for transmitting messages from the brain all around to all different parts of the body. When these nerves are damaged, they can no longer carry the signals properly, which can lead to a wide range of symptoms. These symptoms are usually broken down and categorized into 3 categories. There's motor neuropathy, autonomic neuropathy, and sensory neuropathy. Motor neuropathy is caused by damage to the nerves that control muscles and movement in the body, and therefore cause symptoms such as muscle twitching, muscle weakness, or in severe cases, complete loss of motion. Autonomic neuropathy deals with damage to the nerves that control the things in our body that we do without thinking, like breathing, our heartbeat, and digestion. And for those reasons, damage to these nerves is especially dangerous and probably the most dangerous out of all these 3. Sensory neuropathy is caused by damage to nerves that control what you feel, for example, feeling pain or sensing temperature or just feeling a light touch on the body. So people suffering from sensory neuropathy may experience tingling, numbness, or reduced perceptivity. For the sake of this study, we will only be focusing on sensory neuropathy since the bumps test is used to isolate this symptom as a means of diagnosis. So now that I have my question, the device I'm going to use to answer it, and a knowledge of exactly what I was testing, it was time to design the experiment. So the first step of the study was obtaining the boards, because not much research can be done without them. Since these boards are still new technology, you can't just go to the store and buy them or order them on Amazon. I actually needed to go down to the lab where these tests were developed and ask permission to borrow a set of boards from the engineers who made them to use in my study. So over here is just a picture of what 3 of the boards that I used to actually conduct the research. And this is the lab at the University of Minnesota where I went to pick it up. So along with this first step, I also had to learn how to administer the test. Up on the board are instructions developed by the people who made the test that just give a kind of rundown of what you should disclose to the patient before having them run through the test. And it just ensures that each subject has an equal understanding on how the test works before taking it, as a way of just leveling the platform and reducing variables. So the second step was selecting my methods of measurement for fingers. And this may sound like a self-explanatory step, but through trial it became quickly apparent to me that measuring a finger with just a straight edge ruler was not an easy thing to do, and it's not a very accurate way to do it either. So what you see on the screen is an electronic digital caliper, and that's what I use to measure the width of people's fingers by pinching their finger between these 2 prongs, and it's a very precise way of doing things, so that's what I found to be most effective. But as an alternative method to that, I also had subjects take down 4 fingerprints of which I measured the width and averaged it out as an alternative way of obtaining measurements. The third step was obtaining the subjects to be involved in the experiment. I started by making an announcement to my AP research classmates and then branched out by asking other students individually to be a part of the study. I knew I wanted to have a relatively even number of males and females in the study to ensure a vast range of hand sizes. And by the end, it was down to, I had 9 females and 8 males participating in the study. I also virtually eliminated age as a factor in the study by having all the subjects be within the age range of 17 to 18. Sort of as a sub-step to step number 3, I also distributed these consent forms, which just disclosed about what the experiment was and some of what they would be experiencing, as well as ensuring their privacy and letting them know I wouldn't be using names in the presentation or study. So step 4 was actually conducting the experiment. On the left, we see one of the subjects feeling the tile and participating in the test. And on the right is the scoring sheet I used to determine correct answers and record score. So these numbers that you see on the bottom are actually the height of the bump that that the person is trying to detect, and they're given in microns, which is 1/10,000th of a centimeter. The circled ones are the ones with the bump in it, and you sort of just move from the highest quantity to the lowest quantity until they stop being able to detect. So the fifth step was to record and analyze the data. I did this by organizing all of my data in a Google Sheets, as you can see on the board. And then I used the data to make a scatter plot that would visualize the correlation between sets of data. So here's all the here's all the things I measured. Time taken and squares covered just talks about how long it took for that to administer the test, which I didn't end up using in the analysis really, but here are the results. So this graph is the main graph that I used. And as you can see, there is a general trend as you move to the right on the finger width. The perception threshold also goes up, meaning the people with the larger fingers were not as able to detect the smaller bumps. And then this is also just a graph. This is the fingerprint width on the x-axis instead of the fingerprint with the caliper measurement. And as you can see here, it also has a pretty visual correlation. And this is perception threshold as a function of finger length, measuring the long way of the finger. And here's more of a scattered plot. We don't really see a correlation in this one. So that's what an example of something that wouldn't be correlated would look like. So, does this answer the question, can a correlation between finger size and one's perception threshold be determined? And the answer is to some extent, yes. We saw with these two graphs on the left that there was some sort of pattern. As you move to the right, you also move up. So what does this mean? Well, this conclusion can be used to develop a more accurate baseline perception threshold for people at risk for neuropathy, which will make diagnosis using the bumps test slightly more sensitive to change and therefore more accurate. It also suggests that sensory nerves in our hands become less dense as the hand grows, which could be relevant information in monitoring and diagnosing neuropathy in kids whose hands are still growing. In terms of limitations, sample size was the biggest limiter. The small sample size leaves some uncertainty in the results. While there seems to be a direct correlation, including more subjects would have made the data much more irrefutable. Another limitation was that the study failed to consider that any of the subjects had any kind of condition that would affect their perceptivity prior to taking the test. And that's my presentation, and here are my references.
A couple of questions. How did the choices you made when designing or implementing your research method impact your process of research?
Sure, yeah, so the choice to use the bumps test as my means of testing the sensitivity quantity allowed me to already have an outlined procedure before I even started conducting trials, as this is a device that's been used to do similar types of research before. So this actually made the data collection process relatively efficient, and it allowed me to look back on why I may not be, allowed me to look back on why I may not be seeing the results I was looking for.
Okay. How do your findings provide direction for future research?
Yeah, so the further research that could kind of be conducted after this would be in relation to age as well as gender, and sort of encompassing all three variables with including hand size as well. And that, I think, combining these three factors would be able to make a personal perception threshold that everyone, and personal to each individual person, I guess.
Okay, all right. How did your expert advisor facilitate deeper understanding of the research process in general?
So the guy I used to, the guy who I spoke to, who who recommended the bumps test as the tool to use, Mr. Camilleri, was an extremely helpful resource in guiding me through the process of experimental design, as he had done his own type of research that was pretty similar to mine, so that was really helpful. He also helped answer any questions I had along the way, which was also very helpful.
Okay. Thank you. Another round.